Today we're going to be talking about the chain rule for derivatives. So we introduced it in the last video when we talked about sine and cosine. So the derivative of a function inside a function. Okay, so a composite where we have something on the inside, the derivative of that is going to be the derivative of the outside function with respect to the inside function. So the outside function, you're going to take the derivative, the inside's going to just hang out, and then you're going to multiply that by the derivative of the inside. So we have, this is one of the most important rules and sometimes the overlooked, which is why we're introducing it right away, that anytime you have a function inside a function, so we'll do this example here in a second, we have an outside function, which is x cubed, and an inside function, which is x squared plus 3. Before we do this, let's review the rules that you know so far. So at this point, you have our power rule. So if you have anything to a specific power, that derivative is nx to the n minus 1. This includes functions like square root, which is 1 over 2 root x, and you can derive that with this, we did already. If you have 1 over x, that's x to the negative 1. So you end up with 1 over negative x squared. We have the derivative of sine is cosine, and we have the derivative of cosine is negative sine of x. So these are the derivative rules we know right now. We are going to continue to add to that. Today we're just going to be using these functions in composite functions. So I do want you to make a note card with this definition so that you can refer to it as needed. So let's go ahead and find this derivative. The derivative, so it's going to be the derivative of the outside. So 3, we leave the inside alone. So we took the derivative of the cubic, then we're going to multiply that by the derivative of the inside, which is 2x. Now I'm going to do it by expanding it first, then, and there was a bell. I'm going to expand this first and then differentiate. So this is a cubic one. So again, we're going to use Pascal's triangle and the binomial theorem to do this derivative, or to do this expansion. Okay, so we're going to have 1 times x squared cubed plus 3 times x squared squared times the 3 plus a 3x squared to the first power times 3 squared plus 1 times 3 cubed. Okay, when I simplify all of this down, we're going to have x to the 6th plus 9x to the 4th plus 27x squared plus 27. Now we'll take the derivative, just using the power rule. So this is going to be 6x to the 5th. Multiply this down, so 36x cubed. Multiply that down, 54x, and then the derivative of a constant is just 0. Now we're going to compare that to this one. So they look different, but perhaps they are in fact the same. So I'm going to expand this one out too. So we're going to have 3 times, if I square this, we're going to have x to the 4th plus 6x squared plus 9 times that 2x. So I'm going to have a 6x times each of these. So we'll have 6x times x to the 4th, which is going to be 6x to the 5th, 6x times 6x squared, which will be 36x squared, and then 6x times 9 is 54x. So this and this are the same. So there's not always just one way to do a problem. So this problem, you can use the chain rule, or you can expand it and find the result. All right, so more chain rule. So my outside function is this fifth power. So this is going to be 5, leave the inside alone, to the fourth, then multiply that by the derivative of the inside. So the derivative of 4x squared is 8x plus 8 plus 0. And we're going to leave it just like that. One thing in AP Calculus is if it's a free response problem, you do not need to simplify. So you can leave it like this. If it's a multiple choice, then you would need to simplify to arrive at the right answer. But for today, all we're going to do is we're going to do the derivative and stop there. So let's do this one. Bring down the power. So 4, leave the inside alone, cubed. Multiply that by the derivative of the inside, which is going to be 6x. Okay, here you could write this to the 1/2 power if you choose, or we're just going to use our rule. So the rule for square root is it's 1/2 root, in this case, x cubed minus 2x plus 5. And then we're going to multiply that by the derivative of that, which is going to be 3x squared minus 2. All right, another power rule. So we'll multiply by the power, so negative 2/3 x to the negative 2 plus x to the negative 1. We're going to subtract 1 from this. So if I'm subtracting 1, that's subtracting 3/3. So we'll have negative 5/3. Then I'm going to multiply this by the derivative of the inside, which is going to be negative 2x to the negative 3, because we're going to subtract 1, plus a negative 1x to the negative 2. Let's put that in parentheses. And you could just say minus x to the negative 2 if you wanted to there. Okay, cosine 2x. Derivative of cosine is negative sine 2x, and then we'll multiply that by the derivative of the inside, which is 2. This one's a little bit tricky because identifying the outside function versus the inside function, this notation makes it less obvious. But this notation is just the same as cosine of x squared. So even though the 2 is on the inside, the squared is actually our outside function. So the derivative here is going to be the outside function, so 2 times cosine of x times the derivative of the inside, which is a negative sine of x. Okay, versus this one where cosine is the outside and x squared is on the inside. So these two are just opposites of each other. They're flipped. So the outside, negative sine times x squared times the derivative of the inside, which will be 2x. Cosine of cosine. So our outside is cosine. So we're going to have negative sine, leave the inside alone, times derivative of the inside, which is negative sine of x. Okay, here my outside is cosine. So this is going to be negative 7 sine pi t squared times the derivative of the inside, which is going to be 2 pi t. Okay, this one, again, I'm going to rewrite it. I'm going to make this cosine of x squared squared. So I actually have 3 equations here. So we have an outside, a middle, and an inside. So this is just gonna be like a waterfall. It's just gonna keep flowing. So we're gonna have f prime. We start with the outermost function, which is this outside squared. So this is gonna be 2 times this whole thing, cosine x squared. Then we dig a little deeper. Derivative of the cosine x squared is negative sine x squared. Then we go 1 deeper to the derivative of this, which is going to be 2x. So you just keep digging down until the very inside function. Next one. This one is the same as sine of 4x squared minus 6x plus 9 to the 4th. So when I take that derivative, we start with the very outside, which is the 4th. So we have 4, everything stays on the inside, sine 4x squared minus 6x plus 9 cubed. So we dealt with the 4th power, then we dig deeper to the sine. So the derivative of sine is cosine. And then we'll dig deeper. Derivative of 4x squared is 8x minus 6. Oops, sorry guys. So that's our entire derivative. So we go from the outside to the middle to the inside. So we end up with the outside derivative times the middle derivative times the inside derivative. All right, so here's why. The derivative, we're going to start with the outside. So the outside function is the square root. So we're going to have 1 over 2 root cosine 3x. That's the outside. Then we go to the middle, which is cosine. So that's going to be a negative sine 3x times the derivative of the inside times 3. Now these multiple choice, they know the mistakes you're going to make. They know you're going to forget about the chain rule. You're going to forget to multiply by this. So you might end up with just this because you forget about the chain rule. You might go to here and go, yep, we've got negative sine. Well, they know you're going to do that, okay? So just be careful. Always, if you see answers that have signs, and oh, why do we have that? Chain rule. So when I simplify this, we're going to have a negative 3 on top. So this one is our correct answer. So you do need to simplify or arrive at the simplified answer if needed. Okay, AP loves questions like this where they don't actually give you an equation. You just have to know the rules. So we're trying to find the derivative of f of g of x when x is 1. So we have f of g of x, and we're taking that derivative. So that's going to be f prime g of x times g prime of x. Now we're going to evaluate this at 1. So we're going to have f prime g of 1 times g prime of 1. Now we just start using the table to evaluate these different parts. They give us a lot of information, most of which we're not going to use. So we're going to have f prime g of 1. So we have our x values and we have different functions here. So here's g. G of 1 is going to be 2 times g prime of 1. Here's 1. G prime of 1 is going to be 3. Now we're evaluating f prime of 2. So here's f prime, there's 2. So we have a negative 7 times 3, which is negative 21. Go to our multiple choice answers, and there we go. So that's the chain rule. Like I said, this is one of the most important rules. It's never going to go away, and you're going to hear me say a lot, chain rule, chain rule, chain rule, because we're going to use it a lot. Thank you.